Yeah, welcome you once again to this YouTube channel. In this particular video, we're going to be solving the October-November 2023 multiple choice questions. All right, so we encourage that you continue to share content like this with your friends and subscribe to our channel so that you could benefit from content like this. So let's go straight to answering questions. All right, so we have the first question here. Right, it says part of a cooling curve for water is shown, and then what we'll simply be doing is to apply the same principle we've talked about several times, which is to eliminate any wrong option to reduce the chances of getting it wrong. Okay, so this is a cooling curve. Okay, we know that water boils at 100 degrees, so the boiling point of water is around 100 degrees Celsius, and freezing point is around 0 degree Celsius. Okay, so it says what is occurring between points X and Y. You can see that point X and Y, there is a steady line there. Okay, this shows you that the temperature is steady at that point. So the first option says steam is condensing into water. If you look at it carefully, there is no way steam will be condensing into water at a temperature very close to 0 degree, because that is when it should be freezing, becoming ice. Okay, so that means A is wrong. Now the next one is the temperature of the water is decreasing. Okay, it is not decreasing because you can see that the temperature is steady. Okay, so it is not decreasing, so this is off as well. Now the next one is ice is melting. No, ice shouldn't be melting at very close to 0 degree, looking at it in the form of a cooling curve, so that's equally off. Now, the particles are losing heat to the surroundings is the correct answer in this case. And that is why it is steady in this case, because you see that the particles are trying to form the ice. Okay, trying to form the ice. And that is why they're losing heat to the surroundings so that they can attain that state. Now, the next one is which statements about clean, dry air are correct? Okay, now it's a mixture of elements only. Of course, that is wrong. Okay, we have, if you look at the composition of air, we have carbon dioxide. So this is not an element only, it's a compound. Okay, we also have nitrogen, okay, molecules, oxygens, and several others like the noble gases. So option 1 is off. So if you look at every other thing, which one has option 1? That's off and off. So the next options are C and D. So we have something to work with now. So it's a mixture of elements and compounds. That is correct. It contains only non-metals. Yes, if you look at the composition of air, we see that there are only non-metals present there. So C is the correct answer to that. Now question 3, the representation of an atom is shown. What's the nucleon number? Now nucleon number is the same as the mass number. So nucleon number is simply the number of protons plus the number of neutrons. Okay, number of protons plus the number of neutrons. So the protons and the neutrons exist inside the nucleus. Okay, so this is the nucleus. Now the ones with the positive charge are the protons, while the ones that are shaded are the neutrons. So we count how many positive charge circles we have in there. So we have 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. So 6 of them are protons. Then the neutrons are the shaded ones. 1, 2, 3, 4, 5, 6, 7. So 7 of them. So if you add that, you should have 13 as the answer. Remember that the nucleon number is the mass number, and that's the formula for nucleon number. Right, so this question has to do with percentage abundance. You're asked to find the relative atomic mass of 3 different isotopes of neon. So to do that, we pick the first percentage abundance, which is 90.48. So 90.48, that's percentage 100. So this is the RAM now. We're trying to find the RAM, the relative atomic mass. So multiply that by the mass of the first isotope, which is 20, plus we pick the percentage abundance of the second isotope, which is this 0.27 divided by 100, times the mass of the second isotope, which is 21, plus the relative abundance, percentage abundance rather, of the third isotope, which is 9.25, divide that by 100 and multiply it by the mass of neon at that point. So if you compute this using your calculator, you should have 20.9 as the answer to that. Now question 5, potassium reacts with iodine to form potassium iodide. Which statement about potassium iodide is correct? Now, potassium iodide is a metal and a non-metal, so that's an ionic bond. Okay, so remember, ionic bond is an electrostatic attraction between two oppositely charged ions. All right, and then it involves transfer. But the first option here says sharing a pair of electrons. Sharing doesn't occur here, it's transfer, so that option is off. All right, remember it's an ionic compound. This one says because it's a covalent compound, this is also off. All right, now ionic compounds, you should have high melting points. This is saying low melting point. This is off. So we are left with option B as the correct one. Now, how do you know option B is actually correct? It says in potassium iodide, the particles of potassium have more protons than electrons. Now, potassium before bonding has a proton number of 19. Okay, so when it goes into bonding with potassium iodide, it becomes a potassium ion. All right, and then the number of protons still remains 19, but the number of electrons changes. So the number of electrons in this potassium ion is now 19 minus 1, which is 18. So it proves this statement correct that they have more protons than electrons. Which substance has the lowest melting point? Okay, so let's pick them one after the other. Graphite is a giant covalent compound, so it should have high melting point. Silicon dioxide is equally a giant covalent compound, so high melting point is one of the properties they have. This is a simple ionic compound. Okay, so you should have a high melting point equally. So methanol is if you look at the methanol, it has weak intermolecular forces present there, and that means you should have the lowest melting point as far as these compounds are concerned. And also if you look at graphite, silicon dioxide, and sodium chloride, they are majorly solids. Okay, but methanol has this liquid form. Okay, so that's for that. So we go to question 7. The diagram shows the structure of a molecule of ethyl ethanoate. I have to get the molecular formula. Now, the molecular formula is the simplest whole number ratio of the atoms of the molecule in that compound. What you need to do is to count the number of atoms that are involved. So we have carbon here. How many carbons? 1, 2, 3, 4. 4 carbons. Remove how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens and just 2 oxygens. So that's option B as the answer to that. Now we go to question 4. A hydrocarbon contains 85.7% of carbon by mass. So a hydrocarbon is a compound containing just hydrogen and carbon atoms only. So carbon, hydrogen are the two atoms present here. So we're given that this is 85.7. So to get the percentage of hydrogen, all you need to do is to remove 85.7 from 100. So let's do that. Calculator 100 minus 85.7. And that's a 14.3. All right, so 14.3 is this other the percentage of hydrogen. So divide by their masses, atomic masses rather. Sorry, hydrogen is 1 rather, not 12. So okay, so 1. So we should have, I think, if we do that, 85. Let's do 85.7 divided by 12. Right, we could have I have 7.1 here, so let's say 7.1, and then 14.3 still stays, because 14.3 divided by 1 is 14.3. So divide by the lowest mole ratio here, so 7.1. So this should be 1 and 2. So that's CH2. So option A is the answer to this. All right, so we go to question 9. We're given the formula of a compound containing element X is this. The relative formula mass of the compounds is 158. What is the relative atomic mass of X? So atomic mass of sodium is 23. Consult the periodic table for that. And there is a 2 subscript, so it's 2 times 23 plus 2, the unknown, which is X, so 2X, plus oxygen is 16, so 3 times 16. And everything should sum up to the formula mass of the compound itself, which is 158. So if we compute this, we should have, because of our time, please, you look for X here by simply, computing this and collecting like terms and you find X. Okay, you have to take 2 as the answer. So that's for question 9. Now go to question 10. Dilute aqueous potassium chloride is electrolyzed using platinum electrodes. So which row identifies the product at each electrode? If you have a question like this, write out the cations and the anions involved in this process. So cations are the positive ones there. So we have potassium, and because it's a dilute aqueous one, so hydrogen ion is equally present. Then for the anions, you have the chloride ion, and then you have the hydroxide ion present. Now remember from that for dilute aqueous solutions of very reactive metals, hydrogen goes to the cathode, hydroxide goes to the anode to form oxygen gas. So hydrogen at the cathode, oxygen at the anode. So that's the principle involved there. So the exception is where you're having compounds involving copper. That is when this rule changes, okay, where copper would now be deposited at the cathode instead of hydrogen. And that has to do with the reactivity of hydrogen compared to copper. So those are the foundational things that could help you to solve questions like this as quick as possible. Okay, so we move to the next question, which is question 11. Now, question 11 also on electrolysis. Okay, this is concentrated aqueous copper 2 chloride, just what we discussed earlier. So, but this time we are using copper electrodes, and we ask what happens to the mass of each electrode during this electrolysis. So, at the anode, there is a loss of electron. So, copper loses electron here, and the moment copper loses electron here, the mass of this particular electrode decreases. Okay, so the mass of the positive electrode decreases. So C and D are off already. Now, when it loses electron, the electron goes to the cathode, which is negative electrode, and therefore the mass of this particular electrode increases. So that's B. So loss of electron from the positive goes to the negative, okay, and then it increases the mass of the negative, decreases the mass of the positive. The initial and final temperatures of 4 different reactions are measured. Which reaction is the least exothermic? Exothermic reaction means having a negative value. So we do compute, okay, we have 19 minus 25, that's being minus 6. So 21 minus 8, that is plus 3. 22 minus 17, that is plus 5. And then 22 minus 26, that's minus 4. So the least exothermic, okay, is the one with a lower negative value, and of course that's D. Okay, this is least exothermic. That is, this is more exothermic. Remember, exothermic means you have a negative heat change. Okay, so more negative heat change means it is more exothermic. Smaller value of the smaller value of the heat change in heat or change in temperature shows that it is the least exothermic. So go to question 13. Which equation represents an endothermic reaction? So this has to do with having a positive enthalpy change. So if you look at all of these reactions, we have option B that involves combustion. Combustion is an exothermic reaction. Reaction of metal with water releases energy, okay, it gives off heat. So that is an exothermic. So now we are left with A and C. Okay, so the combination of hydrogen, 2 of these atoms of hydrogen to form the molecule is also endothermic. So our answer here is the dissociation of this chlorine molecule to form this is endothermic. Okay, so that is that. Now question 14, okay, we are asked to find the energy change for this reaction. This is going to be a bit lengthy, but we have to do it so we understand. So methane, we have 4 hydrogens attached to, so we have to get the energy to break the bonds, total energy to break the bonds first. So to break this bond here, this is oxygen itself, okay, so this is oxygen. Okay, so we have oxygen here. All right, so we have to get the energy for the methane itself. So we have how many CH bonds? 4 CH bonds. So it's simply 4 times 410 plus. Now if we look at oxygen, O double bond O. Okay, and then there are two of them, so 2 times 496, so that's what we're going to have for energy required to break bonds. So bond forming now, that is to form the products, we have C double bond O in this case, and then how many C double bond O's do we have? We have 2, so it is 2 times 805 here. Okay, so we have OH, so this is H. So let's have O here, and we have H, and we have H attached. Okay, so H, we have 2 of it. Okay, but there's a 2 coefficient here, that makes it 4. Okay, so let's compute this first. So 2 sets of C double bond O, that's 2 times 805, plus there are 2 OHs. Okay, 2 OH, that's 460 times 2. So we're going to have OH, so that's 4 times 460. Okay, because the first OH 460, the second OH, and that 460, then we have 2, a coefficient of 2 there, so that makes it times 4. All right, so let's compute the energy required to break bonds first. So we do compute that. So let's do it here. So 2 times, so 4 times 410. I have 1640 here, plus 2 times 496. We have 992, so 992. So let's add that up. If you add that up, you sum that up. So 992 plus 1640. I'm having 2632 here. So we have 2632 for that energy required to break the bonds. And let's look at bond forming now. So 2 times 805. Okay, I'm having 1610 plus. Then we're going to do 4 times 460. So 4 times 460, I'm having 1840. All right, so let's add that up. So 1840 plus 1610. Okay, so what I have here is simply 3450. All right, so what we'll do next is the energy required to break the bonds minus the energy needed to form the bond. So 2632 minus 3450. Okay, so if we do 2632, that is the energy change. So energy change is 2632 minus 3450. And from my calculator here, I'm seeing minus 818. So minus 818 kilojoule per mole. So let's see if we have minus 818 here. Okay, so we have it as option A. So that is how to compute energy change. All right, so you could watch it over and over again to get how to do that. All right, we go to question 15. Now for question 15, we have the hydrochloric acid is added to excess calcium carbonate in 2 separate experiments using different concentrations. And of course, you can see the plots that the one of a higher concentration, okay, has a different curve compared to the one of a lower concentration. So we ask now that which row is correct. Okay, so from what we have here in this question, you see that you look at the collision rate in the first one, particles in 2 mole per dm cube compared to 1 mole per dm cube. The particles in 2 mole per dm cube, of course, should have a higher collision rate because there are more particles per unit volume to collide. So option C and D are off already. So it should have higher collision rate. Then the collision energy, should the collision energy change? Let's see. It says, but the temperature is the same in both experiments. So for the temperature to be the same in both experiments, it simply means that the collision energy does not change. So your answer is simply A. Okay, so we go to question 16. The decomposition of dinitrogen, okay, is a reversible reaction. The forward reaction is exothermic. This is very important in solving questions like this. You have to know what the or backward reaction is. So we are told the forward is endothermic. And if the forward is endothermic, it means the backward is exothermic. All right. Now, which row shows the effect on the position of equilibrium and the rates of the reverse reaction when the temperature is increased? Okay. Now, which row shows the position of equilibrium based on the Chatelain's principle? And then, what will be the reverse? What will be the effect of this temperature increment in the reverse? Now, because it is exothermic, when you increase the temperature, the equilibrium shifts to the right. So every option that involves shift to the left is wrong, okay? Because it is endothermic. When you increase the temperature, equilibrium shifts to the right, okay? So when equilibrium shifts to the right, what will be the rate of the reverse reaction? Will it decrease, okay, or will it increase? Now, when equilibrium shifts to the right, you see that the rate of the reverse reaction simply increases. Okay, so the rate of the reverse reaction simply decreases when the temperature is increased. All right? Because the temperature is increased, the rate of the reverse increases. So D. All right, so we move to question 17 now. All right, so we're giving, in the blast furnace, iron 3 oxide is converted to iron and carbon monoxide is converted to carbon dioxide. What happens to each of these reactants? Now, we're looking at oxidation reduction in this case. All right, let's see. We see that in the options, it says, look at carbon dioxide. You see, carbon dioxide, is it reduced or oxidized? So carbon dioxide here, carbon here is +2. Carbon here is +2, oxygen is -2. But when we get here, carbon is +4, oxygen is still -2. So in this case, carbon has an increment in oxidation number. So carbon has been oxidized. So anyone that has carbon monoxide is reduced is wrong. So carbon monoxide is reduced is wrong. Carbon monoxide is reduced is wrong because of this statement here. So that is how we eliminate options, because carbon monoxide wasn't reduced there, it was oxidized. Okay, we can also look at it in a different light because it gains oxygen. Okay, so from carbon monoxide to carbon dioxide, that's been oxidized. So if you don't want to use the oxidation number, you could use the fact that oxygen has been gained. Okay, so we're left with two options now. Now, if carbon monoxide is oxidized, what then happens to the iron 3 oxide? Now, iron 3 oxide, iron moves, we have iron 3 here, so oxygen is, iron is +3 here. Oxygen is still -2, but here iron is 0. So there's a decrease in the oxidation number of iron, which means that iron 3 oxide is reduced. Okay, and that rhymes with option D. Okay, so that is how to get the answer to that. So move to question 18. Which row describes what happens to iron 2 when they are oxidized? Now, when it is oxidized, oxidation means loss of electrons. So gaining electrons is off. Oxidation means loss of electron. Okay. Now, when they lose electrons, what happens to the oxidation number? It increases. So D is the answer to this. So 18 is D. All right, we're moving forward. In which reaction does an acid react with a base? Now, dilute sulfuric acid is added to a piece of magnesium. So this is acid and metal. So this is not acid base. Dilute acid is added to aqueous barium chloride. This is a salt. Okay. Producing a white precipitate. This is also not the reaction. Aqueous sodium hydroxide is added to aqueous copper 2 sulfate. Still the same thing as B. Okay, let's hope that D will give us the answer. So aqueous sodium hydroxide is added to solid ammonium sulfate, producing gaseous ammonia and sulfuric acid. Okay, so this is the correct one. Okay, because this is an acidic one. Okay, it's an acidic salt. All right. So we move to question 20. So D is the correct option to that. So we move to question 20. Which element forms an oxide that reacts with an aqueous solution of a base? Now we know that metal oxides are basic. So metal oxides are basic. Argon is unreactive, so it's off. So B. Sulfur, because Non-metal oxides are acidic, so they could react with aqueous solution of a base. Now go to question 21. Which method is used to produce insoluble salt? Now we all know that the only method used to produce insoluble salt is the process of precipitation. This and this are for soluble salts. Noble gases are in group 8 of the periodic table. So we are given some properties here, all right? So which row identifies the trends in boiling point and in density? All right, if you look at the trend going on here, what you observe is that the boiling point is increasing while the density is equally increasing. So just look at the values and the trend. So you look at B, increasing, okay? That says that. Now, some properties of element R are shown. That's question 23 now. In which part of the periodic table is R found? Okay, so let's look at it. Melting point, high melting point, high boiling point gives us hydrogen gas. That should tell you that element R is a metal. Now, group 8 is not a metal. Group 7 are not metal. So we are left with transitional elements and this. So for transitional elements, they're going to have higher melting and boiling point than this. So option A is the correct one. Now, question 24. Okay. Which pair of compounds shows that transition elements have variable oxidation states? Now, variable oxidation state is we're going to compare some of these elements and see what oxidation numbers they have. So in this case, chromium, in the first compound here, chromium has an oxidation, is a transition element, so it has an oxidation of +3. And the second compound, it still has an oxidation of +3. So it doesn't change. That's not a variable oxidation state. The second one, copper, in the first compound is +2. And the second one is equally +2. So not changing. And the option C, iron is +3 in the first compound and it is +2 in the second compound. So we don't even need to go too far. We see that option C is the correct answer. So for option D, nickel is +2 and +2 in both compounds. So that settles it. So go to question 25. The list gives the order of some metals and hydrogen in the reactivity series. Okay. So metal X is included. Okay. So which row shows the properties of metal X? Now, if metal X is below hydrogen, it will be unable to react with dilute acids. Yes, because acid contains hydrogen, so it should be unable to displace hydrogen in the reaction. So we've cancelled out options that do not align with that thought. So we are left with 2 options now. Now, it says, will the oxide be reduced by carbon? If you look at it, it is way below hydrogen and carbon is somewhere around the middle here, okay? So it's going to oxide reduced by carbon. Yes, it's going to be reduced by carbon because it is below carbon in the reactivity series. So option B is the answer to this. Now, question 26, when zinc is added to an aqueous solution containing magnesium ions, there is no reaction. Which species has the greatest tendency to lose electrons? Now, there's no reaction because zinc is below magnesium on the reactivity series. So the species that has the greatest tendency to lose electrons is magnesium in the ground state. Now, 27, which gas is in the air is needed for iron to rust? Of course, you know it's oxygen. So 27 is settled. We go to 28. Which coating prevents iron from rusting even when the coating is damaged? Okay, it's a coating. So it protects the metal from getting damaged. And that means it is zinc, because zinc acts as a sacrificial metal. It forms an oxide layer that is difficult to penetrate. Verse 29. Why is limestone added to the blast furnace? Okay, we know that limestone is added to be through thermal decomposition. It breaks down to form the calcium oxide that then reacts with the impurities to form the slag. So it is done to react with the impurities to form slag. It is not the carbon monoxide, sorry, it's not the limestone carbon, it's not the carbonate, it's not the calcium carbonate rather that neutralizes the molten slag. It is when it decomposes and it forms calcium oxide and carbon dioxide. So the calcium oxide then reacts with the impurities to form slag. The flowchart stages in the treatment of river, okay, so we have to identify stage J and stage K. Now, if you look at it, you see that After sedimentation, the next thing that should follow is filtration. Distillation has no business in what we are saying here. Okay, so after sedimentation, filtration should follow, and then chlorination before it is sent for drinking. All right, question 39. Now, carbon dioxide acts as a greenhouse gas by interacting with a particular type of energy that radiates from the Earth's surface into the atmosphere. Okay. Which type of energy is involved and what happens when this energy interacts with carbon dioxide molecules? Of course, you know it is thermal energy. So, now, since it is thermal energy, what happens? Carbon dioxide molecules absorb the energy. So, that is what happens. That's 31. For question 32, oxides of nitrogen such as this are formed in the petrol engines of cars. They are removed from the exhaust gases by reactions with a car's catalytic converter. So which rule describes how oxides of nitrogen are formed in a petrol engine and a reaction that happens in the catalytic converter? Okay, so how are the oxides of nitrogen formed? All right, so that is what we are going to look at. Okay, so it says by the reaction between nitrogen and oxygen from air, by the reaction between nitrogen and oxygen from air. Okay, so from the air, all right, by the reaction between nitrogen compounds in petrol and oxygen from air. No, oxides of nitrogen are not in the petrol, so that's off. So I left it option A and B. So by the reaction between nitrogen and oxygen in air, let's look at the reaction, how the catalytic converter works. So of course, this is how it works. So option B is off because it produces this and this, right? Question 33. Okay, we are moving close to the end of the paper. All right, which diagram shows the displayed formula for the named organic compound? Ethanoic. Ethanoic acid should be CH3COOH. So, but there are too many O's here, so this is wrong. Ethene, of course, can't have 3 hydrogens attached because of the double bond. Because carbon is tetravalent. So, ethanol, okay, C2, 5 hydrogens, 1, 2, 3, 4, 5. And then OH. Okay, so we can just use that general formula. This is okay. And then methane, methane is CH4, so this is off. So C is the answer to that. What's the total number of covalent bonds in the molecule of butane? Now you have to be very careful when doing this, because if you do it wrongly, you get the wrong answer. So let's draw butane so we do it together and see how to get the number of covalent bonds. Okay, so we attach 10 hydrogens, 3 here. Okay, so 1, 1, 1, 1, attach 1 here, attach 1 here, attach 1 here. Now, covalent bonds, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's for carbon, hydrogen, so 10. Now, between these two of them, between these two carbon atoms, okay, that's 11. Okay, between this and this, 12. Between this and this, 13. So they are 13. So don't be forced to sum them up and say 14. Okay, so as I said, you need to be careful, and that's why I have to display it. Okay, so question 35 now. Propane reacts with chlorine in a substitution reaction. Of course, substitution reaction, you should know that ultraviolet light is what is required, so that shouldn't take time. 36, the structure of an organic compound is shown. So the question is, which structure represents a molecule that reacts with steam? So a molecule that can react with steam to produce an alcohol is simply an alkene. Now, an alkene with 3 carbon atoms, so that's propane, so D. Which term describes nylon? Of course, you know that nylons are polyamides, okay, polyamides. 38, ethene can be polymerized. When it polymerizes, this is what is going to form. This is going to be the polymer. Now, question 39, acid-base titration is described, okay. So, which use of the apparatus is correct? The 25 centimeter cube of aqueous alkali is measured using a volumetric pipette. This is a very good use of the volumetric pipette. You know, it measures exact volume, and that makes it very accurate. The 25 centimeter cube of aqueous alkali is measured using the lines on the conical flask. No, that's inaccurate. The volume of acid is measured using the measuring cylinder. Not very accurate. A burette would have been better. The volume of acid is measured using the volumetric pipette. That is unsafe. Okay, so we see that the answer to this is A. Okay, I'll move to the last question for this paper. Substance Q is investigated using chromatography. Okay, we have the chromatogram not drawn to scale. All right, what is the RF value? Now remember that the RF value is distance moved by the substance Q, distance moved by Q divided by the distance moved by the solvent front. So distance moved by the solvent front. I'll just represent it this way. Okay, so what was the distance moved by Q? This is Q. So look at the distance, trace it. According to this, it says 83 millimeters. Okay, and the distance moved by the solvent front is 114. So compute that, divide 83 divided by 114. I have 0.72 as the answer. So that's the end of this paper. So thank you for watching.
I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you're giving to them. Thank you very much, and I'll see you in my next video. Bye bye.